Hi everyone! In this section, we will discuss the three main types of organic reactions: addition, substitutions, and eliminations. These reactions are the condition for understanding how organic compounds transform into substance. Okay, let's start. Okay, let's have a quick review. Organic reaction can be grouped into three categories based on what happens to the atom in a molecule. An addition reaction occurs when two or more atoms or groups are added to a molecule, usually across a double or triple bond. This type of reaction is common for alkenes and alkynes, since they have a multiple bonds that can open up to add new atoms. For instance, in the addition of hydrogen to ethynes, C2H4 plus H2 will become C2H6. This reaction is called hydrogenation, hydrogenation, where the double bond in ethynes breaks and hydrogen atoms are added, forming ethyne. In a substitution reaction, one atom or group in a molecule is replaced by other atom or group. This is typical for alkenes and aromatic compounds. For example, in the chlorination of methane, CH4 plus Cl2 will become CH3Cl plus HCl. Here, one hydrogen atom in methane is substituted with chlorine atom, forming chloromethane. An elimination reaction is the opposite of addition. Here, atom or group are removed from a molecule to form a double or triple bond. For example, when ethanol is heated with concentrated sulfuric acid, CH3 CH2OH will become CH2 double bond CH2 plus H2O. Water is eliminated and ethane is formed. This is called the hydration reaction. To summarize, additions adds atoms, substitution replaces them, and eliminations removes them. These reactions are the conditions of many processes in organic chemistry. Last but not least, here are the reference used for these sections. This is the end of slide of sections 1. Thank you.
Have you ever wondered what makes plastic bag, milk jug, and even super strong industrial pipe possible? It was a simple molecule, the alkane. So, alkane is a hydrocarbon defined by their key feature, a carbon-carbon double bond. To name them, we use the EUPAC rules. How to use EUPAC rules? So, first one, find the longest chain that includes the double bond. Second, change the alkane suffix from ANE to ENE. Third, number the chain to give the double bond the lowest possible number. And lastly, add substituent and position number. For example, this molecule, the structure of 2-butane. We can see the name of ENE on the blue line. That means we have alkane. That means it has to be going double bond between the carbon. Then, but on the BUT on the red line, that means we have 4 carbon. How do we make this useful molecule? So, the most common way is an elimination reaction. The process that we can heat an alcohol with a strong acid like sulfuric acid. It effectively eliminating a molecule of water from the structure. This is called dehydration. Alkane are very reactive because of the double bond. They typically undergo electrophilic addition reaction where they open up the double bond to add a new atom. The most common laboratory and industrial preparation method for alkane is elimination reaction, specifically dehydration and dehydrohalogenation. The first key reaction is hydrogenation. This means adding hydrogen. We adding hydrogen with a metal catalyst like palladium. We break the double bond and add a hydrogen atom to each carbon. This converts the unsaturated alkane into a fully saturated alkane. The second key reaction is halogenation. We adding a halogen like bromine. This is often used in the lab as a test for unsaturation. When you add the bromine water, the double bond react instantly, consuming the bromine and causing the red-brown color to disappear. And finally, the biggest real-life use is plastic. Alkane like ethane are the building block or monomer for plastic like polyethylene. Polyethylene is one of the most widely used plastic globally, found in plastic bag, milk jug, and container.
My name is Muhammad Farizat and I will talk about alkanes. Firstly, nomenclature of alkanes. Alkane is a hydrocarbon with a carbon-carbon triple bond, negative C, C+. Secondly, general formula for nomenclature of alkanes is CnH2n, negative 2. Most of alkanes end with negative YNE at the back. For example, ethene, propene, and butane. Number the chain so the triple bond gets the lowest number. Secondly, method of preparation alkanes. The first method of preparation alkanes is dehydrohalogenation of dihalides. Adjacent carbon or geminal dihalides react with alcoholic KOH. Two molecules of hydrogen halide HX are eliminated. Secondly, dehydrogenation of alkanes. Passing alkanes over red hot copper Cu at 300 Celsius remove hydrogen atoms. Lastly, form calcium carbide. Calcium carbide react with water to form ethene. Next is reaction of alkanes. The first reaction of alkanes is hydrogenation. Alkanes react with hydrogen H2 in the presence of metal catalyst. Partial hydrogen form an alkane. Complete hydrogenation form an alkane. Secondly is halogenation. Alkanes react with hydrogen halide HCl, HBr, OHI. It is follow Markov-Nikov rule that explain hydrogen attached to the carbon with more hydrogen. Last but not least, industrial application for alkanes. Firstly, use of ethene in a welding and cutting. It is used OC acetylene welding and cutting torch. For example, when ethene burns in oxygen, it produces a very hot flame, about 3000 Celsius, hot enough to melt and join metal. This makes ethene essential for welding metal like steel, cutting and shaping metal parts in factories and workshops. That's all from me. Thank you.
Okay, I will continue for the last part for this video assignment is the stereochemical. The first one I will present is isomer foundation. Isomer have a two type. The first one is constitution isomer that have a same molecular format but different connectivity with atom. they have a same building blocking atom, like different carbon skeleton, different foundation group potential, different foundation group type. For example, extension group is butana and isobutana. The second type is stereoisomer. There is entity connectivity but defeat stapling agreement of atom. These have a two main type. The first one enantiament and the second one distribution. For example, a cheese and trust to butana. Generalistic have their general property when an object cannot be supremaced on that mirror image, like left and right hand. The same image but not identical image. In molecule, generality exists when carbon atom have a four different subtypes. Enantiament is a molecular mirror image that non-superimage mirror image of the other. They have identical physical properties like molecule point, boiling point, and solid subsolid that increase fluorescent light and increase inventory. That using raise RS in nodes or positive basement there. Optical activity. Optical physics priority of sterility compound the root plane light. When the light pass through a solid of chemical molecule, that plane of polarism rotate. Like clocking with rotate and counter clocking with rotate. Okay, this session point mirror. They are not mirror image each other. This session have a different physics and chemistry in it. Then in molecule, when the molecule switch, a number possible switch is equal to n. The key properties is different physics properties like molecule point, boiling point. Okay. Most compound this intermission when can cancel Moshi comment that intermission to make the molecule superimposed on the mirror image that cancel the charity image. How to identify Moshi component? The first is identify the stereon. The second step looking the summary, and the last step is a very mirror relationship. Okay, last is rhythmic mixture is a queen amount of the initial resulting in the zero optical activity and as the rotation cancel each out. Okay, that all. Thank you.